Hello, everyone. Welcome to the Aurora for Enterprise session. And thank you for taking a 5-floor trek to get all the way here. We just wanted you to have a look from the top of how Aurora looks. Everybody's having a good time at re:Invent so far? Awesome. Just before we start talking, just a show of hands, how many of you are already using Aurora for preview or after once we got GA? Excellent. And how many of you are from enterprises or companies that are currently using Oracle as the main database? SQL Server? MySQL? You're in the right place. My name is Abdul Sattar Said. I'm the product marketing manager for Amazon RDS, and I have with me GM for Aurora and MySQL, Debanjan Saha, and Robin Williams. Robin Matthews from Expedia, our esteemed customer. So we thought, everything we do here at Amazon is for you. We start with you, end with you. We start with figuring out what exactly is that you need, what are your pain points, what is the stuff that you would like to see us do, and then gear towards it. So we thought it's important that we have a speaker from our customers to tell the story of how exactly they are using Aurora and what they are seeing. Though I'm product marketing manager, I'm quite a technical guy for a long time. I've worked on enterprise databases and enterprise applications for over 23 years. And that time, I have really developed a great appreciation for the role of database in the enterprise. In the enterprise IT landscape, I don't think there is anything else as critical as the database. Your applications can go down, come up, they can be switched out, swapped out, your servers can be changed, but your database cannot be violated. The database cannot go down because there are so many applications that are dependent on it. There is so much critical data related to your business that is residing in it. So when we got onto building a database that's at enterprise class, we looked at it with all the seriousness of how it should perform, what it should be able to do, and what shouldn't happen to it. So if you think about the pain points of any enterprise when it comes to database, it can be basically summarized in these 4 points. What basically an enterprise needs and wants and wishes for is a database that is extremely highly available, that actually kind of like stays up no matter what. Because there's so much running on it, so much depends on it. And performs consistently. And then the performance of the database a lot of times depends on your workload. So you want the performance of the database to adjust according to the workload. Because if you take any business, whether it is a retail business or an accounting business or a service business, the usage patterns for the database is not the same. They vary quite a bit, based on the seasons, based on what you're doing with it. So you want the database performance to remain consistent no matter what you throw at it. And then this is not a reality, but this is something that a lot of enterprise wish for, that you want a database that doesn't need an army of experts to maintain and manage and patch and tune and take care of, right? In a way, it's kind of like similar to an automobile. If you think about how automobiles were 60 years ago, I think a lot of people in this room are quite young. So probably you haven't seen all those automobiles where you have to clean the carburetor and maintain your clutch and gear and whatnot. So if you look at the 1930s car, it's pretty interesting. It's nice to have as a collectible item. But I would really like to drive something a lot more sophisticated under the hood for my long-distance drive or the commute to work. Right? I don't want to depend on something that was designed and built a long time ago. And when it comes to cost, that is a major pain point a lot of customers have when it comes to database. Databases are very expensive, especially enterprise class databases are very expensive. And as the hardware that's underneath changes, most of the database vendors come up with new ways to charge the customers. It used to be based on power units, then it used to be based on number of users, then number of cores, plus users, sometimes number of cores, a lot of different things. So when we looked at it, we figured out the databases that are in existence today do a great job. A lot of them have the features and capabilities that enterprises need, but they are not implemented in a very modern way. So we decided we should probably go back to the drawing boards, take another look at it, and see how we can design and build something for you that kind of like stays from the outside. It actually gives you the same functionality as you have it today, but fulfills all these things that I told you about, all these wishes that you have. So we built Aurora. We went back. A lot of stuff that you see in Aurora is made possible because of the fact that it's a managed database. So if it is something where somebody builds as a software and gives it to you where you go and implement, many of these things couldn't be done. So because this is a managed database, we can do a lot of things that cannot be done on-prem or in your data center. So this is a database with real enterprise class availability and performance, and no licenses for you to worry about. So like I mentioned previously, that's one of the major pain points for customers, right? You are locked into a specific number of licenses. You have licenses for 10 sockets or 300 processors. That's all you can use. And you have already paid for it, whether you use it or not. For many enterprises, whether you are in travel business or you are in retail business or service business, whatever else, your month-end closing for your financial books and probably bi-weekly or monthly processing of payroll puts so much, taxes the database so much, you are going to need a lot of database performance at that time. And unfortunately, because of the kind of licensing you are bought into, there's no way you actually scale up your database. Because the 100 licenses that you have for the database, that's all the 100 that you can use. So here, we actually took away all that pain. There are no licenses for you to worry about. And in addition to that, the total cost of the database with the same performance as an enterprise class database is 1/10 of the cost of an enterprise class database. So I think all these things together make Aurora an excellent fit to be used in the enterprise for various different applications that you use. A lot of enterprises have many custom-made applications built in-home to service the needs of the business. All these are an excellent fit for Aurora. There are a lot of MySQL-compatible off-the-shelf applications, which are, again, a perfect fit for Aurora. There are applications that are built specifically and supported only on specific proprietary databases like Oracle and SQL Server. Many of them will slowly will start supporting Aurora as well. So this will be a good time for you to actually start contemplating how to actually move them to Aurora. Some of the things that we have implemented in Aurora for availability and performance is 6-way replication at the storage level. So we have 6 replicas of the data that automatically happens without you having to do anything. Think about how much pain is involved in setting this up with a proprietary database. It's possible to do with Oracle or SQL Server or any of these other databases that you can buy, but it needs a lot of work, a lot of expertise, and a lot of maintenance. Here you go, do a bunch of clicks, all this becomes available to you. And when you do those clicks, under the hood, there's a lot of stuff that's happening, which is happening automatically because it's a managed service. Just like many of you who raise your hands who are using Aurora today or tried it out in preview, you can see a lot of customers have already started moving to Aurora. So this is just a small sample of the customers who have started using Aurora. So already, you can see some of the big names, including our friend's company here, Expedia. GE Oil and Gas, Pacific Gas and Electric is using Amazon Aurora from some really mission-critical workloads. Probably some of you might have attended a session by Alfresco today, who's actually, who had done a whole bunch of testing with Aurora on a database that's serving 1 billion documents for their CMS with 3 million ingestions per second. That's some mind-boggling numbers. Now, when it comes to setting up high availability or scalability or fault tolerance in commercial databases, as I mentioned previously, there's a lot of stuff that you need to do. If you go to bookstores or Amazon.com, you can see tons and tons of books written on the best practices for setting up high availability for SQL Server or best practices for implementing enterprise-class Oracle. When it comes to doing the same thing on Aurora, I would think it'll be just a couple of pages. The first page will probably read like, launch Aurora with 3 clicks, because we are taking care of all those best practices for you. Now, to tell you more about what happens when you do those couple of clicks to launch an Aurora, here's Debanjan Saha.
All right. Thank you, Abdul.
Thank you.
Hello? Yep. Okay. So, I'm going to talk about how we achieve or what kind of availability, performance, ease of use, cost differentials that we have compared to commercial databases. But before I do that, let me give a little bit of a context in terms of the design philosophy behind Aurora, right? If you look at the traditional databases, the relational databases, not much has really changed in the last 30 years or so. We have a monolithic stack where you have SQL parsing, transaction processing, caching, logging, and then you have storage. And each of these essentially stayed within one machine. And when we created clusters, we have taken the same stack and replicated that in multiple machines. We haven't really done much more than that. So when we started thinking about Aurora, we started thinking about what is that we can do differently in a cloud architecture, right? So what do we have in cloud? We have hundreds of nodes, right? We can create a multi-tenant shared environment. We can do massive scale out. Can we take advantage of that and do something which is more fitting for a cloud architecture? And it's not completely done yet. We have started doing it. And what we have done first is we have taken the logging and the storage layer, combined them together into a scale-out multi-tenant log structure storage system, which is purpose-built for databases. So this is not something like an iSCSI storage or NFS storage or fiber channel storage that you're all used to when you run enterprise databases. It's a custom-built, shared, highly distributed scale-out storage, which is log structured. And only thing we send from the database instance, essentially the redo log records that goes from the instance to the storage, and we generate the data pages right at the storage layer, right? So that is one fundamental innovation that we have. The second thing that we did is that, think of this as a database service built on top of a bunch of microservices architecture, microservices component. So we used Amazon EC2, so we don't use any specialized hardware for storage or servers. We use EC2 instances. We use VPC for security. We use DynamoDB for our control plane. We use simple workflow for automating some of the vanilla tasks that help simplify database management. We use Route 53, et cetera. We take advantage of S3, for example. A lot of you who have managed databases know that taking backups is big pain in where, right? So in case of Aurora, backup is all automated. So whenever we write something to storage, we also send the same log record to S3, and we need to recover from S3, restore from S3, that process is very simple and very accurate also. You can go back to pretty much any second in the past and restore your snapshot. So with that introduction, let me talk about high availability. This is something very, very important for enterprise databases. If your database is not up and running, then nothing else is important, right? So how do you do high availability in Aurora? So again, this is where probably the most fundamental innovation in Aurora is. As I said, that our storage layer is a distributed scale-out storage layer, which is spread across 3 different availability zones. Each availability zone is really a data center. So you have a shared storage volume, which is distributed across 3 data centers, and you have hundreds of nodes within that shared storage volume, each running tens of SSDs, so you essentially have thousands of SSDs over which you are spreading your data. And what we do, that every data set that we have, every piece of data that we have, we replicate that 6 times across 6 different storage nodes across 3 different availability zones. That's what gives the availability that you see in Aurora. And within that structure, our reads and writes are quorum reads and quorum writes. So we write 6 copies of the data. They go to 6 different storage nodes. This is for one piece of data. For a different piece of data, it will go to another set of 6 different storage nodes, right? And as soon as we get response back from 4 out of them, we consider the data to be stable. So you don't have to wait for all 6 to respond back. For reads, it's 3 out of 6 read quorum that we do, although in most cases, we know that who has the most recent data, and we really don't need to wait for 3 readers to give us data back. In the background, we are also doing peer-to-peer replication between the storage nodes. So for example, if we have a storage node which is falling behind, or if a storage node which, for example, had a crash, when it comes back up, it's going to have a peer-to-peer replication with its neighbor and fill the holes it has in the log sequence. We are, in the background, also continuously scrubbing data blocks. We are monitoring all the nodes, repairing all the disks, and all of this is happening transparently, and you don't know anything about it when you operate the database. So how do you tolerate failure? So I talked about 4 out of 6 quorums when you write. So if you have, for example, entire data center going down, right? You have 2 copies of data going down, but still you have 4 available. So you still have write quorum. And when you have 1 more node going down or a disk going down, you can still tolerate that for reads. So the read availability is when you have 3 copies of the data available, you have read availability. When you have 4 copies of the data available, you have write availability. And that gives you pretty strong availability in terms of loss of data centers, loss of nodes, network partition, loss of storage devices, loss of disk, right? So that's kind of the fundamental architectural innovation in Aurora that gives us a huge benefit over the traditional database architectures, even when you move them to cloud. So a couple of other interesting things. Another big differentiator in Aurora is crash recovery. If you have worked with databases, you know that crash recovery is painful. Specifically, if you're working, for example, we compared with MySQL here, but other databases are not entirely different, is that you checkpoint every so often, maybe every 5 minutes, and then you store your logs. When you come back from a crash, you replay the logs, and often the replay is single-threaded, and it can take minutes, sometimes more than a few minutes to do a crash recovery. In case of MySQL, it can be pretty long. In case of Aurora, because of the architecture that we have, logs are actually stored in the storage nodes, right? So you're not storing, you are distributing them across hundreds of storage nodes, and when you come back from a crash, you are applying the logs on demand and asynchronously. So you don't have to wait for all the replay of the logs to complete before you come back from crash recovery. That gives us near instantaneous crash recovery, which is very, very useful in an enterprise database environment where you want to recover from crash very, very quickly. So all of this leads to very quick failover and very predictable failover in Aurora. If you look at MySQL, for example, when a database fails, after that you had to do failure detection. then two things happen in parallel. There is recovery going on in the database node, and then there is a DNS propagation going on, which lets the application know what is the IP address of the new master. And the recovery in case of MySQL, because the crash recovery is pretty much unpredictable, can go over for a long time, and it's very difficult to predict how long it will take to do a failover. In case of Aurora, after the failure is detected, and it takes about 15 seconds, which is not very different from what we have for MySQL now, although we are working on reducing that to 5 seconds. The two things, again, happen in parallel. The recovery is going on, but in our case, recovery is actually very, very fast. It takes from 5 to 20 seconds. And the DNS propagation also happening in parallel. So it's the maximum of those two, which is what it takes to do a failover. Now, what is interesting is that we have a custom driver, and this is in collaboration with MariaDB, and the driver works for both MySQL, MariaDB, as well as Aurora, where you don't have to wait for DNS propagation. So the driver has access to a system table in the database and can figure out who the new master is without having to wait for the DNS propagation to complete, right? That saves about 20 to 30 seconds in some cases. So if you use the MariaDB driver, the Aurora failover can happen in less than 30 seconds. And our goal actually is to take it down to less than 10 seconds, and hopefully in the next few months we'll get there. Continuous backup. This is another, I think, key innovation in Aurora. So what happens in case of backup is that, as I said, the storage is striped across multiple storage nodes. We call protection groups, right? Let's call these segments. And parallelly, for each segment, we take full snapshots every once in a while. The interval of that is dynamic. It depends on the amount of load you have the storage node. That is kind of the long bars that you see. And we also stream all the logs to S3 along with the snapshot that we take every once in a while, right? Now, let's say you have to recover, you have to do a point-in-time recovery, which is the dashed line that you have there. And all you need to do, essentially, get back the full snapshots of those segments, the last one that you have taken, walking back from this point-in-time recovery that you want to get to, and retrieve all the log records and apply those in the storage nodes in parallel again, and you get your new recovered volume, right? Very, very quick, both taking the backup as well as doing a recovery from the snapshot is very, very efficient, right? It doesn't really depend on size of the database because we are doing everything in parallel, multiple storage nodes. So going to performance, so we have done, like everybody else, benchmarking. We have used sysbench on an 8XL machine in this particular case. We have done that for other machines also. And as you can see, with sysbench running simple writes and simple reads, we get 100,000 writes per second, and we get close to about 600,000 reads per second. That's a pretty impressive number even for commercial databases. If you compare this with MySQL, our numbers are 5 times better, right? But as you can say that anybody can generate a benchmark number based on whatever data set you pick, whatever number of connections you pick. So we did some scaling test. We scaled the table counts. We increased the table counts from 10 to 100 to 1,000 to 10,000. And as you can see, the Aurora performance doesn't really budge. With 10 tables, you have 60,000 write IOPS, again on an 8XL. With 100 tables, you have 66,000. And with 10,000 tables, you have 54,000, pretty much in the same range. So it's pretty independent of number of table count. And if you compare those on MySQL running even on local storage, our numbers are up to 11 times better. We also changed the size of the database, 1 GB to 10 GB to 100 GB. We have done tests for larger databases also. In fact, Aurora does very well compared to MySQL when the size of the database increases, right? And you can understand why, because we are using our storage so much better. And in this particular experiment, you can get up to 60 7x better scaling factor when you compare to MySQL. We scaled the number of user connections. And we started with 50, we went up to 500 to 5,000. Again, in this case, Aurora performance kind of goes up from 40,000 to 71,000. And with 5,000 connections, you get 110,000 write IOPS. Now, one thing I should mention here is that Aurora actually does very well in terms of write throughput, because we have done a lot of optimization in the way we handle parallel threads. For example, we have a lot of lock-free data structure, which makes handling of multiple threads very, very efficient. In case of MySQL, as you can see, with 5,000 connection, the throughput goes down to 13,000 writes per second, again, on the same 8XL. And if you look at the headline numbers, it's up to 8x faster than what you can see in MySQL. I'm not going to get into the details of this. If you're interested in how this works, Anurag Gupta actually gave a talk on deep dive on Aurora, and there are a lot of things discussed in detail in his talk. But how do we achieve these numbers? We do that by doing less work. We do fewer IOs. And one of the reasons we do fewer IOs is that we are not really, for example, doing the full data page writes into our storage. We are just sending the log records to our storage. So the volume of writes that we do, that's roughly about 1/50th of what you see in MySQL. We also minimize the network packets. We make better use of the cache. We offload some of the database functions to storage nodes. And we also work more efficiently. A lot of our processing is asynchronous. We reduce latency paths. We use lock-free data structures wherever possible. So a lot of hard-nosed engineering, which contributes to performance improvement. Now, going to the next section that Abdul promised, that we are easy to use, right? So we offer Aurora as a managed service. What does that mean? If you look at databases, they are hard to manage. And if you look at the amount of time people spend in managing databases, 20% of the time goes in backup and recovery management. 40% of the time goes in installing, upgrading, patching, and migrating. And then other things you do, for example, performance tuning, security planning, and many other functions. Now, Aurora is offered, and if you have your database on-premise, then these are all the things you have to do yourself, starting from power, HVAC, network management, rack and stack, server maintenance, OS installation, whatever have you. And then you have to do your database functions, which is database software install, patches, backups, high availability, and whatnot. If you come to EC2, for example, or any cloud for that matter, EC2, of course, does that better than many of the other ones, is that some of these functions are done by AWS, right? Your power, HVAC, your rack and stack, server maintenance, OS installation, et cetera, is done by AWS. When you come to Aurora, which is a managed service on top of RDS, which is our relational database management service, most of the things with respect to database management, starting from power, HVAC, all the way up to database install, patches, backups, high availability scaling, all done by RDS with our APIs. And only thing you need to do is to focus on what differentiates your business, which is essentially application optimization, and some of that Robin is going to talk about. So there are a few things I wanted to mention. I didn't want to get into too much details with respect to all the things that we do in RDS. A few things I wanted to highlight. One is advanced monitoring. If you are running an enterprise class database, you want to have good visibility into what's going on in the database, right? And databases are becoming complex. They are not really just databases. It's part of a big end-to-end application stack. And you would like to manage everything yourself or everything on a single pane of glass, where monitoring streams coming from applications, web servers, as well as databases, you want to put them together on a single dashboard. And in order to do that, you need to have databases providing all the systems level, OS level, as well as database level metrics. And what we are doing is that we already have about 15 or so metrics or 20 or so metrics available, but we have added a lot more metrics that we are monitoring and making available so that it is very, very transparent to you. So what we see is what you see, right? There is no difference between a managed service and something you manage yourself. And all of these is going to be available either through AWS Console, where you can monitor all these metrics and you can create your own dashboard. And by the way, you can, for example, move things around so that the layout is what you'd like it to be. You can have some of the graphs bigger than the other ones. You can set alarms. And more importantly, you can actually will be able to vary the granularity of the metrics. You can retrieve them from anywhere between every 1 second to 60 seconds. And you can then pipe those metrics. These are all JSON files which are streamed into CloudWatch logs into any third-party tools, monitoring tools that you may be using in your environment. So think of it this way. Let's say you have a Graphite dashboard, and you want to see your end-to-end application stack monitored on that dashboard, right? Some of your app servers are running in EC2, some may be on-prem. You have your web servers running in EC2, you have your database running in RDS. RDS will provide you the monitoring stream that you can integrate with any of your favorite dashboards, and you can have a complete end-to-end view of your entire application stack at one place. It's a pretty cool thing if you're running enterprise apps. So what about cost? Right? Ultimately, it boils down to, well, all these are good features, but how much does it cost? So this is what we have for Aurora. The R3 large, which is the smallest instance we have, is about 29 cents an hour. And the largest instance we have, R3 8X large, is $4.64 an hour. There is no licenses, no lock-in. You pay only for what you use. And if you are using reserved instances, you get pretty good discount. 44% for 1-year reserved instances and up to 63% with 3-year reserved instances. And if you compare that with what you get from commercial vendors, and you compare this with Oracle, Aurora has a lot of unique features, which are all included in the pricing that we told you. But if you get, for example, Oracle licenses, first of all, you have to start with Enterprise Edition licenses in order to get your enterprise features. But then you have to pay for your data guard, that's extra dollars. You have to pay for your backup in the cloud, that extra dollars per channel. Then you have to pay for your security, which is extra dollars per core. So all of this adds up. And I wanted to do a simple model. Take a commercial database on EC2 and do an hourly cost of that, right? So this is an 8XL with 6 terabyte of storage, 30K PIOps. Your instance costs $2.93 an hour. Your enterprise licenses is $26.30 an hour. Your storage is $3.75 an hour. And you have added 3 replicas to that, and that's typically configuration a lot of customers have seen using. And the total cost for this configuration comes to $131.92 per hour. If you map this to an equivalent configuration of Aurora, what you have is a single storage volume, because it's a shared storage, and your primary as well as your replicas read from the storage volume. It is $5.15 for the storage, and Aurora on 8XL, including the instance, costs $4.65 an hour. And if you add all of this up, it's $23.71 an hour, roughly about 82% of savings. Now, actually, if you want more savings, I know that Dave Lang, our product manager, is waiting there at the back with $50 credit for you to go and try Aurora. But now you're wondering, okay, you sold me. How do I get in there? And we just announced our AWS migration service. And using AWS migration service, you can move data from any database into Aurora. In fact, you can move from any database to any other database. But in this particular case, you can move from Oracle or SQL Server or MySQL or even from another Aurora instance. And it happens while your applications are running, right? The way it works is that you start your replication instance, then you connect the source and target through this tool or service, which is another instance essentially running. And you select your tables, schemas, and databases, and then the tool automatically starts migrating that to the other side. And once the migration is complete, you can cut over. It's near zero downtime. Of course, there is a little bit of downtime when you cut over, but almost no impact to the application. We also have another tool, which we just announced, this reinvent, is the AWS schema conversion tool. When you are migrating from Oracle to SQL Server to something which is MySQL compatible, you require to convert your schemas. It's not just moving your data, right? So with the schema conversion tool, you can move your tables, views, stored procedure, your DML to Aurora as well as MySQL and MariaDB. It's essentially the same technique. And it pretty much does, from what I understood, also depends on your particular environment, 80% of the job. And 20% of the cases where you don't know how to do the conversion, it will highlight that so that you can go to those specific areas and do it manually, right? Pretty good improvement from just trying to do it everything manually. So let me stop here. And Robin is going to talk about, they just moved to Aurora. He's going to talk about his experience. Thank you, Robin.
Hi, everyone. My name is Robin Matthews. I'm part of the Expedia Worldwide Engineering Organization, and I'll be talking about my team's journey towards Aurora. So before we get started, in this presentation, I'll be talking about a lot of different database technologies and why it didn't work for our particular use case. But I want to caveat that those same technologies are very actively used for very different use cases in different parts of the company, and they work perfectly fine. So with that caveat, let's get started. I'm guessing most of you have heard of Expedia, but for those that haven't, we are one of the largest travel companies in the world. To give you an idea of our size, last year we did more than $50 billion in gross travel bookings. We have a broad range of supply across different lines of businesses like flights and hotels, and we also have a large cross-section of brands and websites across different parts of the world that generate a lot of demand for us. So a little introduction of my team. So we call the Lodging Inventory Services, or also known as the LIS team. And think of us as sitting between a service layer, sitting between our hoteliers and Expedia. So Expedia provides a lot of tools, depending on the type of hotel. If you're a small hotel or big hotel, you get different tools. And the hotels use those tools to actually work with our marketplace, right? Update rates, inventory, availability. And all of those tools actually go through the LIS service layer before those updates make it into our marketplace. I have some of my team members here in the front row. So Anil, Jeff, and How, do you want to quickly stand up? So in case you want to talk to us about our journey later, we'll be around for maybe 10, 15 minutes. You can swing by. So let's talk about the use cases. At a high level, I would put it in two categories. One that I call finding the needle in the haystack. So a good example of this is dispute calls that we get from our hoteliers. So occasionally, a hotelier, typically during invoicing time, they might give us a call and say, hey, we think you booked our room at the wrong rate. It should have been $150, but we see that you made the booking for $100. And we need data, historical change data, to kind of prove or disprove their statement, right? So we have tools today that can actually pull up everything that happened to a room rate, and we can tell the hotel in very minute detail what exactly happened. So in this case, it's quite possible that the hotelier was kind of right because they did around that time make that rate update to $150. But guess what? Maybe the commit happened 2 seconds after that booking. So we're able to show them that, hey, yes, you changed it to $150, but guess what? when the booking happened, it was still $100, and they're happy, we're happy, right? So that's one use case. So it's really looking for those specific records in a huge swath of data. And unlike the image over here, they're not going to wait for 65,000 seconds, right? So they really need that response pretty quickly. The second use case is what we call value-add features. So an example of this would be, hoteliers wanting to know what the guy across the street is doing in terms of their pricing their rooms, right? So we would want to give them information, historical trends, maybe even future stay dates, like what is their competition doing in the next week? How are they manipulating their rates? So again, we need this change data that I was talking about to be able to generate those trends and share with the hotel. So now that I've talked about those use cases, I want to give you guys an idea of the size of the data we're talking about here. So any guesses from the audience on how many changes we see in the Expedia travel marketplace on a typical day? Any guesses? Several thousand? Much higher. Any other guess? Sorry? 1 million? Close. So we do roughly 300 million updates a day, and this is a typical day. We might have a busy day, maybe several of our big partners are doing full refreshes, and we could see like 1 billion plus updates happen on a single day. Now, if you think about the use case I mentioned earlier, right, about having the dispute resolution, typically we want to keep this data around for 2 years. So think about that, 300 million updates a day, keep that data around for 2 years, ideally, right? And obviously, we want to do this at minimum cost, and we also want super fast response times when we're querying that data. So before we talk about the different solutions we looked at, I want to spend a little bit of time on what we use today, right? So all of the stuff that I described, we are actually doing today, and we have a SQL Server infrastructure that supports it. It worked very well for us back in the day, even until a few years ago, but as our data size has grown, it started, as all of you here using SQL Server knows, it's really hard. So we've done the typical things like, we've used tier 1 SAN for fast I/O. We have obviously partitioned and scaled out, so we're able to scale out, but it is not as easy as AWS, right? Nothing is happening, nothing is elastic or automatic, right? You have to keep an eye on it and do it yourself. And the cost, if you think about licensing, the hardware, storage, especially the tier 1 SAN, the cost tends to get really high. So one of the first things we looked at was Cassandra, along with Apache Solar. So the reason we started off, we thought it would work well with our use cases, and we had a couple teams in Expedia that had some success with this. But one of the issues we ran into, because of the type of querying and response time needs that we had to have a lot of indexes, not just 1 or 2. And what we saw is that as our data size grew, the Solar indexes got really huge. And that would have meant we needed a lot more hardware in our Cassandra ring, adding to the cost. So it was not that viable for us. And this is around the time we started exploring AWS. And we started with MySQL, and we started really simple. We went with JPA, no provisioned IOPS, no table partitioning, single inserts. And we got a performance of roughly 400 inserts a second. We did some of the basic tuning. We used JDBC. We started doing batches. We provisioned IOPS, and we were able to increase the performance significantly to around 5,000 inserts a second. But what we saw is that we were bottlenecked at that after around 300 million rows. And the other thing was, I talked about the amount of data. MySQL supports just 6 terabytes of storage, and that certainly wouldn't have worked for us long term because our data was growing by leaps and bounds. And like I mentioned earlier, we need to store ideally the 2 years worth of data. So this was around the time Amazon introduced Aurora, so we had a portion of the team tinkering with it. We were able to use a lot of our learnings from MySQL and port it over. And right off the gate, we saw much improved performance of about 25,000 writes, inserts a second, with peaks of up to 70,000. This was with one month's worth of data, and our reads and writes were super fast as well. So I guess in summary, the early results look promising. We've already started migrating the 2 years of data that I'm talking about, and early results show that the performance continues to stay similar as our data size is growing. And the other thing that works for us, the 64 terabytes, right? So I think that covers us for some time. I mean, we can definitely migrate, do 24 months of data, and then our data is growing as well as we add more and more hoteliers. So we should be able to, this should sustain us for the near future. So I guess, in conclusion, what I would say is that you really need to think or really understand your use cases in detail before you can kind of narrow down a database solution that might work for you. But even after that, I think until you actually put your real data through those systems and try it out, you're really not going to know how it's going to perform for you. So that was, I guess, the lesson learned for us. And hopefully, you guys in the room can take a little bit out of that. So that was it from my side. Thank you.